For part A, there's no point in trying any prime number in the 20s because if we say looked at 29, then we know that when we square an even number, we get an even number. We square an odd number, we get an odd number. We're going to do even plus odd, we're going to get an odd. So let's not look at any of those. So what we need is prime number where both digits are odd, because we know then when we square them, we still get odd digits. And when we add two odd numbers, we get an even number. So the first one that jumps out is to try 31. Then we do 3 squared plus 1 squared if we follow the process, and then I get 10, which is even. And that's a counterexample. This is a counterexample. It's good to write a little conclusion, but we are done. For the second part, prove that the sum of the squares of any 3 consecutive positive integers cannot be divided by 3. So a good idea is to say the first one's n, let's say the second one is n plus 1, and so the third one is n plus 2. That makes them consecutive. So the sum of the squares of these will be n squared plus n plus 1 squared plus n plus 2 squared. We just need to write along at some point that n is itself an integer. Then I can expand these out. So I don't need to expand out n squared. If I expand this one out, I'm going to get n squared plus 2n plus 1. And then the third bracket is going to be n squared plus 4n plus 4. I can collect my terms. So I've got n squared, and n squared. I've got 3n squared. I've got 2n and 4n, 6n. And I've got 1 and 5. Sorry, 1 and 4, which gives me 5. So that is the sum of my consecutive integers. I just need to now show that this cannot be divided by 3. Well, looking at it, we see the first term is divisible by 3, the second term is, but the third term is not. And that's almost enough. A good idea is just to write it. So I'm going to write it as 3 plus 2 at the end, and then factorize out a 3 as much as possible. 3n squared plus 2n plus 1. So I've got my multiple of 3 here, and then I'm going to get this 2, which is going to be a remainder when I divide by 3. So this is not divisible by 3. It's enough just to write that. Divisible by 3, and you can just write proof complete or QED.